All right, so today we're going to talk about solving polynomial equations. We talked about dividing out polynomials before. And so like I said, we're going to talk about extending our conversation on solving quadratic equations, right? It's going to be the same principle, but we're going to have higher ordered polynomials that we need to worry about dealing with. So we got to be able to solve polynomial equations by factoring. And if you paid attention to the last set of notes, you will notice that none of that had anything to do with solving equations. There wasn't an equal sign anywhere in there. So now we're going to put in an equal sign and start looking at solving equations. So when we do this, remember that finding solutions is the same as finding roots, which is the same as finding zeros, which is also the same as finding x-intercepts. And so we're going to want to keep that in mind too as we start looking ahead at graphing polynomials in the future. Okay? Now, solving polynomial equations is the same thing as solving quadratic equations in that we're going to utilize what's called the zero product property. We talked about that before. Zero product property says if you're going to multiply stuff together and they have to equal zero, that means one of them has to be zero. To utilize that, our equation has to be equal to zero. So same thing here. We have to get our equation equal to zero in order to use that property, much like we did for quadratic equations. So to do that, I'm going to go ahead and add the 20x squared and the 50 over to the other side, because this will be 0, this will be 0, and so I'll just get 0 on this side. And we get 2x to the fourth plus 20x squared plus 50. Okay? And now what we're going to do is we're going to factor. That's what solving by factoring means. Solve by factoring means we're just going to factor. So let's factor this trinomial down. First thing we always look for is a GCF. It has one which is a 2. So we're going to factor out a 2. And then we want to factor down that trinomial. Now it's a degree 4. But it will still factor down into two binomials, and that's because the first term is an x to the fourth, the second term is an x squared, so that means I know that I'm going to factor the first guy down into x squared and x squared, right? And because those coefficients are both a 1, all I need now are factors of 25 that will add to 10. Well, that's 5. 5 and 5. Okay? So I've got 3 factors, and what I would want to do is keep looking inside the parentheses to see if I can keep factoring. Right? Inside of here, there is an x squared, so maybe we can factor it. But x squared means that we're looking for a difference of 2 squares, and this is not a difference. This is a sum. So neither one of these two are going to give us the opportunity to factor some more. So what we do now is we implement the zero product property, which says that if I want to multiply any number of things together, right, 2, 3, 4, 17, whatever, however many, if I'm going to multiply a bunch of stuff together and they have to give me 0, then that means that one of those guys has to be 0. In other words, set all your factors equal to 0 to see how we can make them 0. Find out what we have to plug in for x to make them 0. Now, well, there is no x for this first guy, 2 equals 0, so that's not going to give us a solution. But there is for the other two guys. Now, the nice thing here is the two factors are the same, x squared plus 5 and x squared plus 5. So if we solve one, we've solved them both. So what we're going to do here is take a look to see how we can solve this. And it's a quadratic now. X squared is a quadratic term. So we go through our quadratic equation solving methods. Square root method first. Can we use the square root method? Well, we're missing a b term. So the answer to that is yeah, we can. So all you got to do now is subtract 5 and then square root both sides. There's a negative inside that radical, so we got to pull an I out. We always have to remember to do a plus or minus in when we square root method. And so we got x equals plus or minus I square root of 5. And we would get the same thing for the other x squared plus 5 equals 0, so there's not really much of a reason to work that out. So our two solutions, remember there's two solutions in here, are positive I square root of 5 and negative I square root of 5. Just again, some foreshadowing for you. What does it mean if our solutions are all imaginary? Well, like I said, solutions, roots, zeros, and x-intercepts are all the same. So if your solutions are imaginary, that means that your graph is not going to cross the x-axis. There's not going to be any x-intercepts. Okay? All right. So that's it. We're just going to factor and set our factors equal to 0. That's our process. Okay? So you give it a shot. You're going to have to be able to factor by now. If you can't factor by now, you're going to have to get in here and get some help, or this is going to be very miserable for you. Okay? But go ahead and get your equation equal to 0. Try to factor that and stop the video and start it back up and see if you got it right. Okay, so this is what you should have gotten. You got to subtract 21 from both sides. Get you 2x to the 4th plus 11x squared minus 21 equals 0. Then you have to be able to factor that down into 2x squared minus 3 and x squared plus 7. Okay, now, got your two factors there. You want to look inside the parentheses to see if you can factor some more, but you can't. Those are not the difference of two squares. So we can't keep going there. So what we do is we set our factors equal to 0. 2x squared minus 3 equals 0. We can use the square root method because there's no b term. So you add 3, divide by 2, and you get x squared equals 3 halves. Square root. And so we go plus or minus. And then we split this up into the square root of 3 over the square root of 2. But we can't have that radical in the denominator. So multiply the numerator and denominator by square root of 2. And we get the square root of 6 over the square root of 4, or just 2. Right? So that's the first guy. The second guy we have to go ahead and set equal to 0 and solve also, because it's not the same as the other factor. Now we square root, and so we get, there's a negative inside that radical, so pull out your I and do your plus or minus. And so look at this. We've got two solutions here, positive square root of 6 over 2 and negative square root of 6 over 2. And we've got two solutions here, positive I square root of 7, negative I square root of 7. 4 solutions, right? 4 solutions, and that actually makes sense. The last problem I know this didn't work out because our two of our factors were the same. But whatever degree our polynomial is, that's generally speaking how many solutions we're looking for. Okay? And so we should be looking for 4 solutions. All right? All right. Still looking for those solutions, roots, zeros, x-intercepts. This guy right here. Again, it's a degree 4, so we should be looking for 4 solutions. To solve this, we need to get it equal to 0. So we get 16x to the 4th minus 81 equals 0. Now, this is a difference of 2 squares. You can square root both of those terms. And so this will factor in that shortcut way, right? Square root 16, you get 4. Square root x to the 4th, you get x squared. Square root 81, you get 9. And so we get 4x squared, 9 over here. And then we do our plus or minus because our smiles need to add to 0 because we're missing that middle term. But again, just keep factoring, right? Always look inside your parentheses to see if you can keep factoring. And we can factor this guy down right here. So we're going to keep the 4x squared plus 9. And we've got a difference of 2 squares here again. So square root these guys. And then go plus or minus. Now we've got three factors. We want to set all three of these guys equal to 0 to find all four of our solutions, hopefully four of our solutions, right? So we can use the square root method for this first guy, subtract 9 from both sides, divide both sides by 4. So we get x squared equals negative 9 over 4. Now when we square root, we got a negative inside the radical, so we're going to do a plus or minus and pull out an I. And then we get the square root of 9 over 4, which if you square root the numerator and the denominator will give us plus or minus 3/2 I. There's two solutions there. The next two are going to come from setting 2x plus 3 equal to 0 and 2x minus 3 equal to 0. So now subtract 3, divide by 2. Add 3, divide by 2. And there's your other two solutions. So again, not always are we going to find four solutions, but that's kind of a pretty good guideline. So 2 there, 3/2 I and negative 3/2 I, and then 2 below, negative 3/2 and positive 3/2. Okay? Like I said, we're just factoring and setting our factors equal to 0. Okay? Here's another one for you to try. Go ahead and give it a shot. Stop the video, start it back up when you're done, and check your answers. And this is what you should have gotten. You should have gotten plus or minus I square root of 45 over 9 and plus or minus square root of 45 over 9. Those are your four solutions to this guy, right? So definitely, if you want to, pause the video and check out my work versus your work and make sure that you understand what's going on. If you don't, come in during STAR and we'll take a look. Okay? All right. Still other factoring situations, right, that we want to take a look at. If we want to solve this guy, again, we're trying to find solutions, roots, zeros, or x-intercepts. Got to get it equal to 0 first. And we get 8x to the third plus 125 equals 0. Now, this is two terms. You can't use the square root method, even though it's missing a b term, because you can't square root x to the third, right? And factoring this down, well, two terms, and we can't square root them. We can't square root 125, and we can't square root 8. We can't square root x to the third. So you have to remember your cubes, right? This is a sum of cubes. I can cube root 8x to the third, and I can cube root 125. When I cube root each of those, I get 2x here, and I get a 5 here. So you have to remember our little formula for factoring down our cubes. You always put the cube roots in the first set of parentheses, 2x and a 5. Then you square that first guy to get the first guy in the next set of parentheses, so 4x squared. Square root the last guy and put him in the last place here. And then you multiply your cube roots together, so 2x times 5 is 10x. And then you use SOAP for your signs, right? Same, opposite, always positive. And we're talking about the sign up here. Okay? So now we've got two factors, and remember, just keep factoring, right? I want to take a look and try to factor this guy here. But if you remember our conversation from our cubes before, that trinomial will never be able to factor, right? Well, we still have to set these guys equal to 0 and solve them. So for the first guy, it's not a big deal. Subtract 5, divide by 2, and we get negative 5/2. Right? But the second guy won't factor. So remember what we're supposed to be using. This is still a quadratic equation. It's a degree 2 that we're trying to solve. And if it won't factor and you can't use the square root method because it has a b term, then what you're left with is the quadratic formula. So opposite b plus or minus square root of b squared minus 4ac all over 2a. Opposite b gives me 10 plus or minus the square root of negative 10 squared is 100 minus 4 times a, which is 16. Negative 4 times 4 is negative 16. And then we're going to multiply it by 25. And that gives us minus 400. All over 2 times a, 2 times 4 is 8. So we go 10 plus or minus the square root of negative 300, all over 8. Simplify that radical. We got a negative in there, so we got to pull an I out. And then simplify the square root of 300. So we get 10I radical 3. And then you can look at your triangle there and try to simplify that. So we get 5 plus or minus 5I, square root of 3, all over 4. And so there's the rest of your solutions. There's one right here, negative 5/2. And remember that there's 2 wrapped up in the quadratic formula. You go upstairs and downstairs for your 2 different solutions. So 5 plus 5I, square root of 3 over 4. And then 5 minus 5I, square root of 3 over 4. So there's your 3 solutions, right? It was a degree 3. We were looking for 3 solutions. But, yes, quadratic formula rears its ugly head. Okay? All right. Let's keep trying to work on this, right? So this guy's already equal to 0. We just need a factor. And again, difference. It's a difference, and there's 2 terms, but we can't square root them. But we can cube root them. So we got to do our cube stuff, right? This is x and this is 3. So we go binomial, trinomial. Binomial is going to be x and the 3, the cube roots. Then we square the first guy over here, x squared, and that becomes the first guy in the trinomial. You square the 3. That becomes the last term in the trinomial. And then you multiply the cube roots together. So the 3 and the x. And then you use SOAP. Same sign as this guy. Opposite, always positive. And so you got x minus 3 equal to 0. Again, that becomes pretty easy. So x equals 3. But our trinomial will not factor. And so we have to use the quadratic formula. So, opposite b plus or minus the square root of b squared minus 4ac is going to be 36 all over 2. So we get negative 3 plus or minus the square root of negative 25 all over 2. Got to pull your I out. And then the square root of 25 is 5. So you get negative 3 plus or minus 5I over 2. You can't simplify your triangle there, and so you're done with that guy right there. Okay? All right. Why don't you give number 7 a shot here. Stop the video, factor down your cubes, and then do your quadratic formula, and start the video back up, and you can see how you did. So did you get negative 1/4 and 1 plus or minus I square root of 3 over 8? Got to use quadratic formula for that second trinomial. Okay, if not, take a look at my work and see if you can figure out why not. If you can't, come in and see me and we'll work through it. Okay, other forms of factoring. Let's see what else we can do. So here again, our equation has to be equal to 0. So subtract 28. So we get 3x to the 3rd plus 7x squared minus 12x minus 28 equals 0. Okay, let's see. GCF, there's no GCF. 4-term, remember 4-term factoring? The best thing we got is grouping. And then GCF each set of parentheses. So we're going to factor out an x squared here, and we get 3x plus 7. And then we factor out a negative 4, it looks like. Remember, we always factor out that guy. And so we get 3x plus 7 here. And this only works as long as our parentheses are the same, and they are. So our factors are whatever's inside the parentheses times whatever's outside. But just keep factoring, right? Because we can factor that second set of parentheses into x plus 2, x minus 2. And then we can start setting all of our factors equal to 0. So we get negative 7/3, negative 2, and positive 2. Those are all three of our factors. Or sorry, all three of our solutions. Okay? Not so bad. No quadratic formula needed here. Okay? Another one here. Why don't you go ahead and try this. Move everything over, then you're going to have to use your factor by grouping method. So go through and try to factor this guy down and get your solutions. Start the video back up and check your work. And so, did you get 3/2 and then plus or minus I square root of 2 over 2? So a couple of things. When you did your factor by grouping and you looked for a GCF for 2x minus 3, the GCF was just a positive 1. But go ahead, this is the one time where you actually want to go ahead and factor out that GCF of a 1. We've got to see that there so we know what our factors are outside the parentheses. And so your two factors turn into 2x minus 3 and then 2x squared plus 1. Yeah, we do want to look inside here to see if we can keep factoring that guy, but we can't because it's a plus and not a minus. And so you see the rest of the way there. Okay. All right, look at this next one. 3x to the 7th equals 81x to the 4th. Factor it, right? Get it equal to 0 and factor. It's the same process. So we have 3x to the 7th minus 81x to the 4th equals 0. GCF, we still want to pull out a GCF. 3 will definitely go into 81, so 3 and then x to the 4th. When we factor that out, we should be left with x to the 3rd minus 27. Okay? Now, we've got to keep factoring if we can. So this is a difference of cubes. We're going to be able to factor with our cube thing. So remember that in our binomial, we need the cube roots, which are going to be x and 3. In our trinomial, we square the first cube root, we square the last cube root, and then for the middle term, we multiply the cube roots, and then we SOAP it. Same, opposite, always positive from what we were the signs from what we were factoring down before. Remember that in this trinomial will not factor down, so we're ready to go ahead and set all of our factors equal to 0. So 3x to the 4th, the x minus 3, then the x squared plus 3x plus 9. The first one, we divide both sides by 3. We get x to the 4th equals 0. And then we can actually fourth root this, right? Because it's still equal to 0, we can still fourth root that and get x equals 0, right? The fourth root of 0 is just 0. So it's kind of a weird thing that we haven't really seen before, but since the only x that we have in that equation is being raised to the 4th power, that allows us to fourth root both sides. Okay? Then here we're going to add 3 to both sides, of course, and get x equals 3. And then we know we can't factor down this trinomial, so we have to quadratic formula it. So we should end up with this. Pull out your I, square root of 25, you get 5i, and we can't reduce the triangle, and so we stop there. Okay? So tough. I mean, there's just some different tricks to this factoring and solving by factoring. Okay? One last one. You give it a shot, you start the video, start it back up, and check your work, okay? And so this is what you should have gotten. You should have gotten 0 for one of your solutions, and then plus or minus I square root of 30 over 2. So take a look at what I did. If you don't quite understand what's going on there, then come in during STAR, and we'll go over it. Okay? Sorry about that. Homework's out in Canvas. Make sure you have it done by next time.